2.3 Simplifying Variable Expressions. In this lesson, we'll learn how to simplify variable expressions. Let's first take a look at some vocabulary terms. Term: the parts of an expression that are added together. So here I have an example for you. 5x plus 4x plus 7. So each of these, we call them terms. Coefficient. Coefficient means the number part of a term with a variable. So for example, in this expression here, we have 5x and 4x. 5 and 4 are the coefficients. Constant term. The constant term is a term with a number but no variable. So in this numerical expression here, 7 would be considered the constant term. Like terms. Like terms are terms that have identical variable parts. So example, 5x and 4x will be considered the like terms for this numerical expression. All constants would also be your like terms. So for example, in this case, if I have 5x plus 4x plus 7 minus 8, plus 7 and minus 8 will be my constants, or negative 8. Guided practice, Part A. For the given expression, identify the terms, like terms, coefficients, and constant terms. Then simplify the expression. So here, our terms will be 4y, positive 23, you don't have to write the positive in the front, negative 7, negative 6. So if I were you, I would just cut the numerical expression right before the positive and negative signs. And your like terms will be 23, negative 7, negative 6. Your coefficients will be 4. There's only one. Constant terms, 23, negative 7, negative 6. And for this next one here, your terms will be 2b, negative 8, positive 4b, negative 6b. And your like terms will be 2b, 4b, and negative 6b. And your coefficients will be 2, 4, negative 6. And your constant terms will only be negative 8. Part B. In this part, I'm going to justify the steps for simplifying expression with properties from chapters 1 and 2. So let's begin with 4n minus 7 minus n plus 9. I could rewrite this as 4n plus minus 7, or negative 7, plus negative n plus 9. Next, I'm going to use the commutative property of addition and switch the location of negative 7 and negative n. So in the next step, I will write 4n plus negative n plus negative 7 and recopy the positive 9 or plus 9. Now, we know that negative n has a coefficient of negative 1. We can use the distributive property and rewrite 4n plus negative n as 4 plus negative 1 times n, and recopy positive plus negative 7 plus 9. So I'm going to write distributive property. And then we can add this together. 4 plus negative 1 is positive 3n. And I can add the constants together. Negative 7 plus 9 is positive 2. And this would be the simplest form of this expression. Let's take a look at the next problem. In this case, I will first need to simplify 2 times the difference of x minus 4 by using the distributive property. So 2x, 2 times negative 4 gives you negative 8. Recopy 9x plus 1. And then I'm going to write distributive property here. I need to group like terms. I put 2x and 9x together and the constant terms together. And this is the commutative property of addition. And 2x plus 9x gives me 11x. Negative 8 plus 1 gives me negative 7. And this 11x minus 7 will be my expression in simplest form. In this next one, we do the same thing. We recopy 4a. We know that there's a coefficient of negative 1 before the difference of 4a minus 3. So we can distribute the negative 1 in to the difference of 4a minus 3. Okay, so by writing this 1 in here, we call this the identity property. Okay, and I'm going to use the distributive property. Negative 1 times 4a gives me negative 4a. Negative 1 times negative 3 gives me positive 3. Now I can combine like terms. 4a minus 4a is 0. Copy the positive 3. 0 plus 3 gives me 3. Let's take a look at some word problems. During your workout, you spend a total of 45 minutes jogging and swimming. You burn 14 calories per minute when jogging, 8 calories per minute when swimming. As you can see, I underlined all the key information. Part A, let J be the time for jogging. Write an expression in terms of J for the total calories you burn during your workout. Okay, so we know the total time of working out is 45 minutes. 45 minus J is the time for swimming. You burn 14 calories per minute when jogging. So that's the rate. I will write 14J and 8 calories per minute when swimming. So I would do 8 times the difference of 45 minus J. And this would give me the total calories for swimming. And I want to repeat, this 14J will represent the total calories for jogging. So if we add these two terms up, it will represent the total calories you burn during your workout. Part B, find the total number of calories burned if you jog for 20 minutes. So we need to sub in 20 for J. It would be 480 calories. Agriculture. A farmer grows tomatoes and cucumbers in the field shown. The annual cost of growing tomatoes is 27 cents per square foot. The annual cost of growing cucumbers is 10 cents per square foot. Let X represent the width in feet of the tomato portion of the field. Part A. In terms of X, what is the area of the tomato portion, of the cucumber portion? Okay? So here it says, let X represent the width of tomato. So for tomato, let's use T, we would do, because it's 500 here, so it's also 500 here. The area would just simply be 500 times X. And for cucumber, if total height is 800 feet, then the width would be, for cucumbers, would be 800 minus X. So we could take 500 and multiply that by 800 minus X, which would equal to 400,000 minus 500X. Okay, and that's the answer to part A. B, write and simplify an expression in terms of X for the annual cost of growing both crops. So the total cost, I'll use TC, T for total, C for cost, equals, we know that it's 27 cents per square foot for tomatoes. We could take 0.27 and multiply that by 400X. And 10 cents for cucumbers, and multiply that by 400,000 minus 500X. And now we can simplify this expression. 0.27 times 500 should get 135X. And we need to distribute 10 cents into the difference of 400,000 minus 500X. Should get 40,000 minus 50X. Okay, and then we can combine like terms. 135x minus 50x gives you 85x. And this will be the answer for part B. And for part C, find the annual cost of growing both crops if the width of the tomato portion is 350 feet. So TC is sub in 350 for x. We're using the expression from part B to calculate the total cost when the tomato portion is 350 feet. And after doing the math, it should be 29,750 plus 40,000. You should get 69750. $69,750. And that concludes our lesson. Okay, here are some added notes, and let's try some of these. For the given expression, identify the terms, like terms, coefficients, and constant terms, and then simplify the expression. So here, you can cut all of these terms. So here, it's positive 3u, negative 12, negative 4u, positive 28, negative 10u. And your like terms would be 3u, negative 4u, and negative 10u. And you can circle these. And your constants are also your like terms. So you have negative 12 and 28. And circle these. Then here you have your coefficients. So if you look at your coefficients, 3, negative 4, and negative 10. Constant terms would be negative 12 and 28. And we simplify this. We need to add 3u minus 4u minus 10u. So I'm going to rewrite that. 3u minus 4u minus 10u, and then minus 12 plus 28. Three minus 4 is negative 1. Negative 1 minus 10 is negative 11u. And then we have negative 12 plus 28. That's plus 16. So negative 11u plus 16 is your answer. Again, let's do one more practice. All the terms are 6L, positive 32, negative 4L, negative 19, and negative 13L. And your like terms are 6L, negative 4L, and negative 13L. And we can circle these answers. And we have positive 32 and negative 19. Okay, and then we have the coefficients, 6, negative 4, and negative 13. The constant terms, 32, negative 19. And then we can simplify. 6L minus 4L minus 13L, and plus 32 minus 19, 6 minus 4, 2, 2 minus 13, negative 11u, L. And then 32 minus 19 is positive 12. And negative 11L plus 12 is your answer in simplest form.